Okay, so welcome everyone to today's class, and it is lecture number 16 on ray optics. Do we recollect what we did in the last class yesterday? I'd also sent you a sheet in your group in which I had given all the formulas together. Have you seen it?
Yes, sir. Telegram group.
Yes, in Telegram group I had sent you that sheet where I had given you everything about prism. We had seen what is the angle of the prism. A is the angle of the prism. We had seen that if this angle A is less than 10 degrees, do you remember this 10 degrees? If the angle of the prism is less than 10 degrees, then such prisms are known as thin prism. Will you remember this?
Yes, sir.
And we had seen that for a thin prism, the value of sine theta can be approximately taken as theta. Yes or no? No, yes.
Yes, sir.
Okay, just give me a minute. Yes, so I was saying that for a thin prism, the value of sine theta was equal to theta, and we had given some formulae for prism as well as for thin prism. The formula was for deviation, delta was delta 1 plus delta 2, I1 plus I2 minus R1 plus R2. Do we remember all these formulae? Yes or no?
Yes, sir.
We remember these formulas?
Yes,
Those
sir.
are, those are very important formulae because I have seen straight away question coming from these topics. Now, what we are going to do is move ahead and see the next topic here. And the next topic is known as dispersion. Have you heard the term dispersion?
Yes, sir.
Can you tell me, beta, what do you mean by dispersion? You must have read this term in your previous class. I think in 10th standard, probably, you would have heard about dispersion. Can you tell me what is dispersion? Well, if you don't recollect it, not a problem. This is the time that you can understand what is dispersion. What is dispersion? Now, can you read it and tell me? I hope you can see it on your screen. What is dispersion? Do you see it?
Splitting of light.
What of light?
Splitting of light.
What do you mean by splitting of light? What do you mean by splitting of light? You must have seen a rainbow.
Yes, sir.
You might have seen if you have a prism. I mean, it's very simple, a glass prism, and if white light, normal light, white light falls on that prism, and when it gets out of that prism on the other side, from the other side, if you see, you will see that this white light has split. White light basically consists of how many colors?
7 colors. Vibgya.
Vibgyor, 7 colors. Which color has the lowest wavelength? Lowest wavelength. सबसे छोटा wavelength. Which color has the lowest wavelength? Which color has the lowest wavelength?
Red.
Violet has the lowest wavelength. Will you remember this? Violet has the lowest wavelength. Wavelength for violet is the lowest, and wavelength for red is the highest. Do we remember this?
Yes, sir.
Wavelength for the red color is the highest, whereas wavelength for the violet color is lowest. Now, we have seen this formula for a thin prism. Remember, we're talking about thin prisms here. Will you remember this? Whenever we are studying this topic of dispersion in this particular class for your exams, for your JEE or NEET, we are talking about dispersion in thin prisms. Now, when you're talking about dispersion in thin prism, what do you mean by a thin prism? Can you tell me? What is a thin prism?
Angle less than 10 degrees.
Yes, the angle of the prism is less than 10 degrees. We call it a thin prism. Now, for a thin prism, we had found out that this minimum deviation, the deviation for this prism is mu, which is the refractive index minus 1 multiplied by A. Do we get this? Yes or no? No, yes.
Yes, sir.
We had also seen some class and we will see the actual formula, the Cauchy's formula. For any given wavelength, the refractive index is not constant. In fact, if I say very vaguely, but I'm not saying it very exactly, if I say it very vaguely, mu is inversely proportional to the wavelength. Did I tell you that? Yes or no? If some light has large wavelength, the mu for that light, if it is falling on a prism, that mu will be the smallest. Do you get this? Yes or no? No, yes.
Yes, sir.
Mu is inversely proportional to the wavelength. That means mu for violet color. Do you see mu for violet color? Mu for violet color will be greater than mu for red color for the same prism. Same prism we are talking. That means the deviation for the violet light will always be more than deviation for the red light. Do we understand this?
Yes, sir.
That is all that you need to understand in this particular topic, dispersion of light. The first thing that you need to understand is what is dispersion. What is dispersion? When white light falls on a prism, it is splitted into 7 colors. Now, some people may ask you, why do they split into 7 different colors? The answer lies here itself. Light, whenever it is passing through a prism, it gets deviated. The light gets deviated. This deviation depends on the value of mu. Deviation depends on the value of what?
Mu.
It depends on the value of mu. White light does not have a single wavelength. White light has 7 different wavelengths. 7 different wavelengths. Since it has 7 different wavelengths, there are 7 different mu's for all those colors. The mu for violet light is the highest because the wavelength is the smallest. Mu for red color is the highest because wavelength. No, mu for red color is lowest because wavelength is highest. And therefore, they get deviated differently. Which color will get deviated the most? Tell me the answer for this. Which color will get deviated the most? Which color out of all these 7 colors will get deviated the most? The answer is on your screens. Which color will get deviated most, beta? Which color will get deviated the most?
Violet color, sir.
Violet color will get deviated the most because mu for violet is more than anything else. So violet color will get deviated the most and red color will get deviated the least. Do we understand this?
Yes, sir.
Now here is a diagram that is going to tell you the exact thing in a diagrammatic form. You may not have to draw the diagram, but if you can draw the diagram, that is good. This is the diagram that is going to tell you. I'm going to show you two diagrams side by side. Here they come. I hope you can see these diagrams. Do you see on this side what we have? What we have?
White light.
White light. Now it is going through a prism. White light consists of 7 different colors. These 7 different colors have 7 different wavelengths, and therefore 7 different mu's. Mu is inversely proportional to wavelength. Violet has the least wavelength, mu is highest, and you can see violet is getting deviated maximum. You see, this is the deviation of violet and it is the maximum. Do you see this? Yes or no? No or yes?
Yes, sir.
Violet light gets deviated the maximum, whereas red light gets deviated the minimum. Do we see this? I've drawn the angle of deviation wrongly. This is the angle of deviation. If you can see, for the violet light, it is maximum, and this is the angle of deviation or deviation for the red light, which you can see is the highest, and therefore you will find that this white light is getting splitted into 7 different colors because of 7 different wavelengths. Do we understand this?
Yes, sir.
This phenomena is known as the phenomena of dispersion. Dispersion is the phenomena when white light falling on a prism gets splitted into 7 different colors. This dispersion happens because of different wavelengths. For different wavelengths, mu is different. Wavelength for violet is least, mu is highest. Wavelength for red is highest, mu is least. Violet light will get deviated the most. So we will find violet on the lower side, most deviated side, and red on the least deviated side. Do we understand this?
Yes, sir.
Now you may not have to draw the diagram, but you will have to write what is there on your screen right now, and it comes. So I'll give you a minute to note it down. Remember, when we are talking about dispersion, the concept that we are discussing is for thin prism only. Even if it is a thick prism, dispersion will happen, but the formula will not be so simple. That is why we are not discussing that. We are only discussing thin prism. Do we understand this?
Yes, sir.
I'll give you a minute to note it down. The next term is angular dispersion. Can you tell me what is angular dispersion? Yes, anyone? Angular dispersion, it is normally denoted by theta. It is a dimensionless quantity. It has a unit, and the unit is radians because it is in terms of angle. Angular dispersion, that is why the name angular dispersion. Can you tell me what is angular dispersion? You can see it in the diagram over here. What is angular dispersion? Theta. The diagram is also showing you the angular dispersion. Can you tell me what is angular dispersion, bacha? Yes,
Angle of deviation between red color and violet color.
it is now on your big screens. See, we have a deviation for violet, which is the highest. We have a deviation for red, which is the lowest. Difference between the two is known as angular dispersion. So theta, the angular dispersion, is nothing but, oops, I've written the wrong symbol, is Nothing but deviation of violet minus deviation of red. Will you remember this? Angular dispersion theta is the difference in the deviation produced by a prism for violet light, which is the maximum, minus the deviation produced by the same prism for red light, which is the lowest. Do we understand this? Yes or no? No, yes.
Yes, sir.
Just write this and then I will show you at the same time. In this diagram, it would be very clear. The angular dispersion, as you can see, I'll just show it to you. The angle theta is also given. This angle between these two lines is the angle theta. Do we understand this? The difference in the deviation between the violet light and the red light is known as
Angular
dispersion.
dispersion.
Everyone is there with me on this? Can I have some raised hand that we understand this?
Yes, sir.
Well done, sir. I'll give you a minute. I hope you have understood it from the diagram. And here it comes. Here it comes for you in terms of how you write it or how you say it in words. It is the difference of the angle of deviation for violet light and red color, violet color and red color. So this theta is delta V deviation in violet minus delta R, the deviation of the red light. Now you can put the formula for delta V. For delta V, the formula is, what will be the formula for delta V? Deviation for the violet light will be mu for the violet light minus 1 multiplied by A. Do we understand this? Yes or no?
Yes, sir.
Similarly, deviation for the red light shall be equal to mu for the red light minus 1 times A. Do we understand this?
Yes, sir.
When I subtract red from violet, I will get this deviation, angular dispersion. I always say it wrongly sometimes. The angular dispersion is nothing but mu V minus mu R times A. Can I have some raised hands from everyone that we understand this? Angular dispersion theta problems come directly from this topic. Dispersion, dispersive power, deviation without dispersion, dispersion without deviation. These are the only things that we are going to do today. I'll give you a minute to note it down. The angular dispersion theta is delta V minus delta R. If you put the formula, if you put the value of delta V and delta R, you will get mu V minus mu R times A, and your time starts now. What we have seen up till now is angular dispersion. Angular dispersion theta is nothing but delta V minus delta R, and if I put the values, I will get this formula mu V minus mu R times A. Now, one more term we have to understand here, and that is known as mean deviation. Mean deviation. Now, if I look at the spectrum goes like this: V, I, B, G, Y, O, R. Picture. Now, the dispersion, this yellow light lies exactly in between, not in the spectrum when I say it, but when you look at the deviation, this deviation of this yellow light is exactly in between the violet and yellow. So the deviation of the yellow light which is nothing but mu for yellow minus 1 times A. This is known as your mean deviation. Do we understand this? The deviation of the yellow light, is known as mean deviation. Can you note it down, please? The deviation of the yellow light is known as the mean deviation. And this will be equal to mean deviation for yellow light. Deviation for yellow light or mean deviation will be equal to mu yellow minus 1 times A. Do we understand this? Now, sometimes in a question, mu yellow is given to you. Sometimes in the question, mu yellow may not be given to you. So there is a very simple way to find out the value of mu yellow. If mu yellow is not given to you, you can take mu yellow as mu violet plus mu r divided by 2. As I told you, the refractive index of yellow lies exactly in between, very close to the center, in between the violet and yellow. So you can take the refractive index of yellow, mu y, as mu violet, mu v, plus mu r divided by 2. So this becomes the concept of mean deviation. The deviation produced in the yellow light is known as mean deviation. Can I have some raise hand that we understand the term mean deviation? I'll give you a minute to note it down. Please note it down, beta. So we move ahead. We have seen what is deviation. We have seen what is angular dispersion. We have seen what is mean deviation. Now comes the next character, and the next character, the next formula, the next definition is known as dispersive power, denoted by the letter omega. Again, this is unitless and dimensionless. Does not have any unit, does not have any dimension because it's a ratio. It's a ratio. Ratio is just a number. Ratio is just a number. What do you mean by dispersive power? It is the ratio of angular dispersion, d theta, angular dispersion, theta, to the mean deviation, delta y. Mean deviation, deviation of the yellow light. If I divide the angular dispersion, theta by the mean deviation means deviation of yellow light, whatever I get will be known as omega. So this becomes formula number 1 for omega. Do we understand this? Raise hands will give me more confidence. This becomes formula number 1 for omega. And if I put the values, this becomes formula number 2 for the same omega. Formula number 1 and formula number 2 are not different. They are same. This is also formula number 2. Dispersive power omega for a prism is mu violet minus mu red divided by mu yellow minus 1. In most of the cases, red, violet, and yellow mu will be given to you. If yellow mu is not given to you, you can find out the value of mu yellow by this formula, which I've already given you, mu violet plus mu red divided by 2. I hope dispersive power is clear. Don't get confused between terms. The only problem, the only mistake that you can do in this particular topic is mixing of terms. What is angular dispersion, what is deviation, what is mean deviation, and what is dispersive power. If you remember those terms correctly, You should be able to solve any question that comes in this particular category. I'll give you a minute to note these things down. Dispersive power omega, angular dispersion divided by ratio of angular dispersion and mean deviation. Note it down. Also note that this formula for omega has mu v minus mu r and mu of yellow. So dispersive power, a very, very important point. Questions come directly on this. Dispersive power depends only the material of the prism. Dispersive power only depends on the material of the prism. But at the same time, if you talk about dispersion or angular dispersion, dispersion or angular dispersion, or you can call deviation, dispersion or angular dispersion or deviation, it depends on both things. It depends on the material of the prism. It depends on the material of the prism as well as it depends on the prism angle A, prism angle A, because in the formula for dispersion, we have mu V minus mu R multiplied by A. So dispersion also depends on the angle of the prism as well as on the material of the prism. Dispersive power, on the other hand, only depends on the material of the prism. Will you remember this? Can I have raised hand that we understand this? Dispersion depends on two things. Number one, material of the prism. Number two, the angle of the prism. Dispersive power only depends on one thing, and that is your material of the prism. What type of glass that prism is made up of, that is the only thing that determines the dispersive power. I'll give you a minute now so that you can note all these important points. Remember, one of these points would be coming in the examination hall. Since you have done this, now is the time to solve some questions, and here is the first question that is going to come on your screens right now, and the question is here. Can you tell me the answer? A spectrum is formed by a prism whose dispersive power is omega. The deviation of the mean ray is delta. What is the angular dispersion? Can you tell me what is the angular dispersion? Yes, beta. Anyone with an answer? No one knows the answer? A, B, C, D, 1, 2, 3, 4. This is question number 29, which is given on page number, I think, 52 of your sheet. Yes, beta. So, this is very simple. Omega, the dispersive power, is nothing but angular dispersion divided by mean deviation. So my angular dispersion theta becomes omega multiplied by delta, and therefore The answer is D. Do we understand this? Yes or no? No or yes? Can I have some raise hand that we understand this? Everyone, these are the questions that are going to come in the exam. Please don't make a mistake, beta. It will be very sad. All the hard work will go in vain. Can I move on to the next question? Do we understand this? Okay, then comes the next one, and I hope you would be able to give me the answer. Remember, in this question, since you'll have to multiply, divide, and subtract, you might have to do some calculations. So please be careful with the calculation. Here comes the next question. Question number 31 from your sheet. And the question reads like this. The refractive indices is the plural of index. The refractive indices of violet and red light. Violet is more, 1.54. Red is less, 1.52. If the angle of the prism is 10 degrees, what is the angular dispersion? Remember, you might get confused with the terms, and therefore I'm giving you all sorts of questions with all sorts of terms so that your confusion goes away. I'll give you a minute to solve this one, and I'm waiting patiently for your answer. This is question number 31 from your sheet, section B, page number 52, I guess. And you have your minute, which begins now. I hope all of you have done this. Can I have raised hand that all of you have done this? Yes or no? No, yes. It's a very simple question with a very simple answer. They're asking us to find out the angular dispersion. Remember, but angular dispersion is theta, deviation in violet minus deviation in red. I put the values. This is the formula that I get. Mu violet minus mu red. I don't have space here. Multiplied by A. That is what you got to do. Mu violet is given as 1.54. So 1.54 minus 1.52, that will give you 0.02. 0.02 multiplied by 10 degrees. The answer would be in degrees, and the answer would be 0.2 degrees. Option B is the correct option. Do we understand this? Yes or no? No or yes? That is question number 31 with the answer 0.2 degrees. I hope all of you have done this. Is there anyone who could not do this? Please raise hands. That means all of you have done this. That is a great sign that you remember the terms. Remember, the question may not be coming straightforward. Sometimes they might just try to confuse you. And here is an example of how they can try to confuse you. This question number 30, same page, same section. White light is passed through a prism whose angle is 5 degrees. The refractive indices for rays of red and blue color are respectively 1.64 and 1.66. Blue will be more, red will be less. What is the angle of deviation between the two colors? So they are asking you how much deviated are the two colors. What is the angle between the two colors? I'll give you a minute to think about it and give me the answer. Your time begins now. So, how to do it? Remember, they're asking you the angle of deviation, angle between red and blue. Remember, angular dispersion is the angle between red and violet. Red and violet is angular dispersion. And the formula for red and violet, angular dispersion was mu v minus mu r times A. So here, the angle of dispersion or the angle of deviation between blue and red, we know the formula for violet and red, You just have to write the formula for blue and red, and it will be very simple. It will be mu blue minus mu R multiplied by A. That is as simple as it gets. Instead of violet and red, you have to find the angle between blue and red. The refractive index of blue is more 1.66 minus the refractive index of red, which is 1.64. So it is 0.02. 0.02 multiplied by the angle of the prism, which is given as 5 degrees. 0.02 multiplied by 5 degrees. Your answer would be 0.1 degrees. Yes or no? No or yes? Can I have some reason that we understand this? Questions are pretty simple, straightforward. Not even a minute. In 15 seconds, in 10 seconds, you can solve it. But for that, you will have to remember. You'll have to remember what, bacha? You'll have to remember the formula. If you don't remember the formula, then the problem will come. Now, again, as I told you, these questions will involve some calculations. And instead of giving you this, I'll give you this one. So this involves less calculation. So my dear friends, this is the next question. Does not involve that many calculation. Here it comes on your screen. I hope you can see it. Question number 34 is what we are talking about. The refractive indices of red, violet, and yellow are 1.42, 1.62, and 1.5. Remember here, yellow car refractive index is given to you. If it was not given to you, you can always find it out from mu r plus mu v by 2. You have to find the dispersive power of the medium or the prism, and your time starts now. I hope you can do this. You know this, you can do this. Please try. So the question is pretty damn simple. We have to find out what? We have to find out the value of dispersive power, which is nothing but omega. We must remember the formula for omega is mu v minus mu r divided by mu yellow minus 1. Do we remember this? Yes or no? No or yes? Just put the values. Mu violet is 1.62, I think, minus it is 1.42 divided by 1.5 minus 1. So I think you will get 0.2 in the numerator and 0.5 in the denominator. 0.2 divided by 0.5. You can calculate this value, and now you can tell me the answer. And what is the answer for this? The answer will be what? Option A. Do we understand this? Yes or no? No or yes? Everyone in the class, do we understand this? Okay. That is great. So remember, if you remember the meaning of the terms, the question becomes very straightforward. Even if you get numericals, numericals are very straightforward. Many a times you might get theoretical questions on this particular topic, and here is one of those. Let me have the answers for this one. Indicate the correct statement in the following. Which is the correct statement? Statement A. Dispersive power depends on the angle. Angular dispersion depends on the angle of the prism. Angular dispersion does not depend upon the dispersive power. The dispersive power in vacuum is 1. So which is the correct option? I can't see your hand because the thing is my iPad is not there and I'm watching you on a mobile device. thing does not come clear, your mind doesn't work. But I think every one of you can see that the answer is option 2. Yes or no? I gave you as an important point, angular dispersion depends on two things. Two things. It depends on the medium of the prism and it depends on the angle of the prism. The angle of the prism wala concept is asked here, and that is what we have marked it. Do we all understand this? Are we all clear with this concept of dispersion and deviation and dispersive power? Shall I move ahead in life? Life, you have to always move ahead. So this is high time that we move ahead on to the next topic. And again, this might be a bit confusing, but when they make tough questions for NEET, this is the topic from which they are going to give you tough questions, because most of the students and most of the teachers, they normally skip this topic because it becomes very difficult for them to understand. I don't know why it is so difficult. So let us try and do it, because we are in good spirits today. Let us try and do it. The next heading is combination of prism. What happens when you combine two prism? Now, you can combine two, more than two, three, four, five, six prism. That much complicated question will not come. But here, when we are talking about combination of prism, we are basically talking about combination of two prisms. Two prisms. Two prisms. Now, when you combine two prisms, you can combine them in infinite number of ways, but there are two different ways in which if you combine them, you get something very fascinating. The first of this combination, they can be infinite combination. Remember, we are talking about combination of two prisms. So I must write here combination of two prisms. That is better. That is a better heading. Combination of two prisms. Now, they can combine in different ways, but these are only two combinations that we are going to talk about. Number one is known as deviation without a dispersion. And I hope you can see it on the big screen. I can also see it. So it must be there on your screens as well. Deviation without dispersion. Now, what do you mean by deviation without dispersion? It is very evident from the diagram that is drawn there. So what I'll do first of all is to just enhance that diagram and probably show you the diagram itself on the big screen. Here it comes, the diagram only on the big screen. Now, what I have done over here, or what has happened over here, can anyone tell me? Okay, the microphone is not working. As you can see, this is blue prism, prism number 1, and this is the red prism, prism number 2. So I'll just mark them differently. I hope you can see the two prisms. One is erect like this, and the other one is inverted. It's kept ulta, upside down. Number 1 prism, white light is incident on that number 1 prism. As you can see, white light is incident on number 1 prism. It gets dispersed. You can see violet here. You can see red here. It's not marked, but let me mark it. Violet will deviate the maximum. Red will deviate the least. Now what I have done is I have put another prism upside down in such a way that after refraction from the second prism, this is the emergent ray. I hope you can understand the meaning of the terms. This ray, the white ray that was falling, was the incident white ray. When I see the ray which is coming out, which is the emergent ray, and I only see white ray, that means white ray after dispersion by two prism has come out white. White has come out white. That means effectively there has been no dispersion. The white light just got deviated. This type of combination is known as combination of prism, where we have zero deviation, zero dispersion, but the ray has deviated. White light comes out as white light. It does not get dispersed, but it gets deviated. Do we understand this? Can I have some reason that we understand this? I'll again repeat. I have put two prisms in such a way. One is erect, the other one is upside down. The angle of the first prism is A, the blue one that you can see. The angle of the second prism is taken as A dash. It is put inverted, upside down. When I put these two prisms in such a way that white light comes out as white light, that means there is no deviation, there is no dispersion, but there is deviation. This type of combination is known as combination of prism with deviation and no dispersion. Do we understand this? Can I have some reason that we understand this? And that is what is given here. Two or more thin prism are combined in such a way that deviation occurs, that is emergent ray makes an angle with the incident ray, but dispersion does not occur, that is light is not splitted, is known as deviation without dispersion. So here there is no dispersion, so theta dispersion, angular dispersion is 0. Total dispersion is theta 1 plus theta 2. So this entire quantity should be equal to 0. Do we understand this? Yes or no? No, yes. This is what you will write. Then we will move on to the next thing. For deviation without dispersion, delta or theta should be 0. I always say the other thing. Theta should be 0. That means the total dispersion must be 0. I'll give you a minute to note it down. Okay, then let's move ahead. By the definition, we know that dispersion is 0. This is the total dispersion and that is 0. A is the angle of prism for the first prism. A dash is the angle of prism for the second prism. Mu v minus mu r into A is the dispersion for the first prism. Mu dash v minus mu dash r into A dash is the dispersion of the second prism. Both of these should be adding up to 0. From here, I can find out the value of A dash. A dash, the angle of the second prism will be minus mu v minus mu r into A divided by mu dash v minus mu dash r. This negative sign indicates that this prism is in opposite direction. Do we understand this? Yes or no? That is what you need to remember. This is the formula that you need to remember for deviation without dispersion. The angle of the second prism A dash is mu v minus mu r multiplied by A divided by mu dash v minus mu dash r with a negative sign. This negative sign indicates that these prisms are in opposite direction. What do I mean by opposite direction? If one prism is erect, the other prism is inverted. I'll give you 2 minutes to note this down. Very important formulas. If a question comes from this chapter, it will be on this formula. Please note it down. Let's move ahead and see the next topic. As told you, we have to do two combinations. The first combination was there was no dispersion, but there was deviation. So now the second combination is the reverse of that. We have no deviation, so delta is 0. Delta of the light, violet, yellow light is 0. Mean deviation is 0, but there is dispersion. As you can see here, white light is incident. This is prism number 1. The red one is prism number 2. Again, one prism is erect. The other prism A dash is inverted. What do you see? Is white light is coming out, but it is getting splitted. It is getting splitted. So deviation it is getting splitted. So dispersion is there, theta, dispersion is not equal to 0. But the deviation, mean deviation is equal to 0. Do we understand this? Yes or no? So when two or more prisms combine in such a way that dispersion occurs, that white is split into 7 colors, but deviation does not occur, emergent ray is parallel to the incident ray, this type of combination is known as dispersion without deviation. The total deviation will be delta 1 plus delta 2, but it will be equal to 0. This is the deviation, total deviation, that is equal to 0. Here mu is the mean mu dash, or mu is the mean mu of mu of yellow light. So from here I can write a dash will be mu minus 1 into a divided by mu dash minus 1. Remember, this mu is the mean mu. You can take the mu of yellow light, or you can take violet plus red divided by 2. Do we understand this? Yes or no? No or yes? Here the negative sign again indicates that the prism are in a positive. One prism is erect, the other one has to be inverted. The other one has to be inverted. The other one has to be inverted. I'll give you 2 minutes to note this down. There is dispersion. White light is getting split into 7 different colors, but there is no deviation. This is known as dispersion without deviation. Your time starts now. Well then, this Prism wala topic is almost over. Let us go through the golden key points, the important points about this chapter. As I told you, dispersive power, like refractive index, has no units and dimension and depends only on the material of the prism. Remember, dispersion has no dimension, but it has a unit of radians or degrees, angular dispersion, and it depends on two things. One is material of the prism. The second one is the angle of the prism. But dispersive power is a pure ratio. It does not have any unit. It does not have any dimension. For a given prism, the dispersive power is constant. It is minimum for red and maximum for violet, because mu for violet is maximum and mu for red is minimum. Remember that mu is inversely proportional to wavelength. Point number 3, for a given prism, you will have both deviation as well as dispersion. So a single prism will always give you both deviation and dispersion. It cannot give you dispersion without deviation or deviation without dispersion. Only when you combine two prism, then you can have deviation without dispersion or dispersion without deviation. For a single prism, for only one prism, you will always have deviation as well as dispersion. Do we understand this? For a single prism, we'll have dispersion as well as deviation. But if you have a combination, you can have deviation without dispersion or dispersion without deviation. I'll give you 2 minutes to note this down. Okay, then here comes the question which is going to tell me whether you have understood what we have done or not. A flint glass prism and a crown glass prism of angles A dash and A are to be combined in such a way that there is dispersion without deviation. For this to occur, what is the ratio of A dash by A? A dash being the angle for the first prism, flint glass, A being the refractive A angle of prism for the crown glass prism, and I'm waiting for your answers. Give me your answers and we are done with this particular topic. The ratio of A dash by A. What is the answer? A dash by A, A dash by A, A dash by A, the ratio of A dash by A. And the answer is option A, mu yellow minus 1 divided by mu dash yellow minus 1 with a negative sign. The negative sign is not given here, not a problem. There must be a negative sign here. Do we understand this? I told you mu in that formula is the mean deviation, and mean deviation is taken as the deviation of yellow light. So you will always use mu yellow, or you can use mu red plus mu violet divided by 2. Yes or no? No, yes. Do you understand this? Everyone in the class, do you understand this? Well then, that brings us to an end of this particular topic. What we have done in this topic is we have understood what is a prism. What is a prism? A prism is consists of two refracting surface. Both of them must be plane and they must be at an angle. That angle is known as the angle of prism. A single prism will always give dispersion and deviation. Dispersion is the splitting of white light into its constituent colors. Deviation is the angle between the incident ray and the emergent ray. If you can combine two prisms, we can have dispersion without deviation, which is the case that we did just now, or deviation without dispersion, which was the case that we did just before that. In both the cases, we have seen what happens in dispersion without deviation. There is no deviation, there is dispersion. In deviation without dispersion, there is no dispersion, but there is deviation. We have seen the formula for thin prism deviation, angular deviation is mu minus 1 into A. For red light, it is mu R minus 1 into A. For violet light, it is mu V minus 1 into A. We have seen that mu is inversely proportional to wavelength. For red light, wavelength is highest, so mu is lowest. Red light will bend the least, violet light will bend the most, and therefore we have deviation as well as dispersion. Are we all okay with what we have done today in the class? Yes or no? No, yes. I'll wind off today's class here. I'll see you tomorrow with the next topic, and we will try to wind up ray optics as soon as possible. Optical instruments is remaining. Small topic, chromatic aberration is also remaining. Sometimes a question comes from that, so I'll have to cover it as well. I can't leave anything to chance. So I'll meet you in the next class tomorrow. Take care. Have a nice day. May God bless you all.